Hey there, and welcome to Into the Terminal, episode 36. Today we're going to be talking about SSH keys and how to use them. My name is Eric, the IT guy Hendricks, and joining me every episode is my illustrious co-host, Mr. Scott McBrien.
Good
All right,
afternoon.
so let's dive in. Oh yeah, it's afternoon for you. It's still morning here, but I'm told it's 5 o'clock somewhere. So, all right, so SSH keys. So in previous episodes, we've talked about how to connect to remote systems to move files around, to actually connect to a separate system, um, and we've done that in the past using passwords. They're usually encrypted. They're not sent over in clear text, so it's somewhat secure. But one thing that you learn about security as you dive in deeper is it's better to have security in layers. And so what we're going to do today is we're going to have a password to log into a remote machine, but we're also going to add an extra layer. There's this concept in security of something that you have and something that you know. So in our case, we're going to have an SSH key and we're going to have a password. The key is something we have and the password is something we know. So with that said, we'll get a little bit deeper into some of the strategy around SSH keys in the bottom half of the show. But for now, let's dive into our critical path and let's go ahead and create an SSH key. The way to do that is if you have the OpenSSH package installed, which pretty much every Unix and Linux system seems to these days. You'll also have a few other tools, the first of which is ssh-keygen. So we could actually run that command, and we could run just ssh-keygen, and we could generate a key pair. Or we could do one of the things I've done in my home lab is add the -b, which specifies how large we want the key to be. And I think the default's 2048, I believe. But I usually double that and go with 4096 just because, hey, why not? So what we've done is what we've initiated here is basically a command line based wizard to generate a public key pair, or a public and private key pair. So the private key you keep to yourself, the public key you hand out to other users or other systems to enable communication using that key. So the first question that we get asked is, where do we want that key to be? We can give it a custom name, but for today, we'll take the defaults. Now, here's a tricky part. One of the confusing parts about SSH keys is you can actually password encrypt your SSH key. That doesn't replace the password encryption on the remote user account. But for the sake of, well, like I said, we'll get into that a little bit deeper into the second half of this show. But let's go ahead and just create just kind of a standard password. Of course, Shantanu says Red Hat at 123. But we can create a password. We can confirm that password, and you notice that it's generated a private key, which is the ID underscore RSA, and a public key, which is the ID underscore RSA.pub. We can see the SHA-256 fingerprint that was generated, some random art, and now those files are actually available within our home directory in a hidden subdirectory at .ssh. So if in my case /home/eric/.ssh. That dot in front of the directory name means that it's a hidden directory, so keep an eye out for that. So that's step one. We've generated our key pair. Now we need to share it out with a remote system. So step two is we need to do an ssh-copy-id. We're going to go ahead and continue as our RHEL user, but we're going to connect out to client one. Client 1 is just another RHEL 9 virtual machine that we've got here in our lab environment. So what this is going to do is it's going to generate an SSH tunnel, and we're going to authenticate as ourselves. Of course, we're going to accept the fingerprint for the remote system and add that to our known host file. And then it's asking for the remote user's password. So got to pay close attention to the password prompts because it's actually asking for RHEL's password on client 1. So once we type that in, it'll generate an SSH tunnel just long enough to copy over the public key into the remote system, and now we can actually do an SSH over to that system using our key files. So you notice that it's asking us to authenticate to our password or to the passphrase for our key. And now our prompt has changed to be on client 1. One other example before we wrap up, we could, if we go ahead and exit this, we can we could go back to our host system, and we could grab just a generic text file, or we could touch a text file, and we can do the same process with SCP or SFTP. Something worth pointing out is if you have multiple keys in your key ring, so to speak, in that .ssh directory, you can actually use the tac-i option to specify a specific key. So in this case, we'll just use the key we generated just a bit ago, and we can grab like the etc Red Hat release file maybe, and dump it in the home directory of our RHEL user on client 1. Name your service not no tac a.
I think we're struggling with like where the file argument goes in the command that we want.
Oh, you know what it is? It's SFTP instead of SCP.
I am using SFTP.
No, I mean I formatted that command for SCP.
Ah, okay.
Yeah, I'm trying to retrain my brain to use SFTP since SCP's been deprecated.
So that's the SCP syntax.
Yep. And we authenticate with our key. There we go. Scott, anything you want to mention about this process before we transition over?
No, I think this is a pretty straightforward way. I think the biggest thing is like you mentioned, keeping the password prompt straight. So there's a difference between authenticating with your user account and the password associated with your user account on the remote machine versus authenticating with your passphrase that you've assigned to your secret key for comparison. So yeah, I think that's the key thing to keep an eye on when you're doing this.
Pun intended, right? All right. Let's see. So we've gone through how to create a key, how to share that key out with remote systems. So we copied our ID, or we copied our key over. But when we created the key, we actually put a password on that key itself. Now, a lot of times SSH keys come into play using service accounts or something that doesn't interactively log into a remote system. So there might be situations where we'd want to create an SSH key where there's not a password associated with that. Now, Scott, you've been a sysadmin for a long time. Are you pro or anti password on SSH keys?
So I'm pro password or passphrase on SSH keys. There's actually a variety of other tools that help keep that in from being really irritating to manage. So, for example, the SSH agent will actually capture your passphrase and use it for all future SSH connections, but it's a desktop application. So, like if you're logged into your GNOME desktop, it'll prompt you for your passphrase, and it'll supply that on your behalf every SSH connection after that. So there's tools to make storing it with an encrypted passphrase less irritating for the user. But the big thing is, we mentioned in the .ssh directory here. So when we made our key, we made these two files, right? And one is the public key, and the other is the private key. The private key is what has that passphrase on it. So if someone were to get these two files, potentially they could then log into all the places where you have key-based authentication. And it's that passphrase on your private key that keeps them from being able to use just the files as the authentication credentials. So if you made a passphraseless key, if somebody grabs the ID RSA and it's passphraseless, and it's not stored encrypted on the machine, they can now use that as a credential to log in as though they were you. So I think passphrase is the way to go. That's a really long way of saying passphrase is the way to go.
No, I think that provides some really good context. Just remind me not to let you do a security audit on my home lab. To be fair, those are internal accounts, but anyway, that could take us down a rabbit hole.
Indeed.
So we'll keep Scott out of my home lab. But other than that, so yeah, passwords on SSH keys definitely improves the securability. Is that a word? Of your SSH authentication structure. And let's see. So why don't we talk a little bit about that .ssh directory? We noticed that as we progressed through the earlier example, it populated a number of files. Scott briefly explained the difference between the public and the private key, but there's also a couple of other files here, and then one that we'll create that I want to discuss. First is the known host file. This is more of an SSH thing than an SSH key thing, but it's good to know. So you notice that in the left hand column you've got host names, and then you've got what's the word I'm looking for? The first column you have clients. The second column you have the
Algorithm.
Algorithm. Thank you. That's a big word for Friday morning. And then you've got the gosh. And then the next column you've got the actual signature. The I think it's technically a fingerprint from the remote system. So this is when you go to SSH into a new system. So if we were to like do an SSH to client 2, the first time we'd actually be asked to, that's what this question populates. So you notice that we've got the SHA-256, and you've got the fingerprint, and SSH is basically saying, I don't know who this is. We've never talked. Do you want me to add this to a list of future systems? The other one so that's the known host file. And so if you end up keeping the same host name and changing out the system, sometimes you have to go in here and clear out old hosts. Something that I fight frequently with my lab, just because I blow things up and do a demo and then blow it up again. So that's the known host file. So when you get asked that question, do you want me to continue to connect? That's what that file's for. The next file is authorized keys. So the authorized keys file is where our public SSH keys go when we do an ssh-copy-id. So you notice these systems, as we've mentioned in the past, are hosted on GCP. So there's some service level accounts that create SSH keys when the virtual machine is spun up. So you notice that we've got SSH-RSA and then a long string that is basically the public key stored in a file. In fact, some of them maybe not in this example, but sometimes at the end of that long string, you'll actually see the user and host name that originally generated the key. So it could be E. Hendrick at client 1. Let's see. I'm trying to move through these files quickly so we can get to another cool example here. Scott, anything else to mention on known hosts or authorized keys?
Yeah. So as you mentioned, I pulled up client 1, and we can see here's the authorized key that we used, or that was added to it when we did our SSH copy ID. I did want to make a note on the known hosts file. So 1 second. There we go. So the purpose of the known hosts file is really to protect someone from a man-in-the-middle attack, where someone sits in between you and your intended system, pretending like they're the intended system. And that's why, like when we connect to client one here, we expect for it to transmit this data back to us. And when it doesn't, the SSH client is going to throw an error message. And it's going to look pretty gnarly that because we're expecting this piece of data and the machine reporting to be client one is not sending us what we expect. And as Eric mentioned, like sometimes that's expected, like in a lab environment where you've blown up a machine and recreated it, right? It's a new box. It's going to get new things like new host keys, and so having a mismatch there may not be scary. But if it's a box that you contact all the time, and then all of a sudden one day it's like, oh, we don't have the correct SSH key, that might be eyebrow raising. Um, and maybe you contact the administrator and be like, hey, did you recently change the SSH keys on this box? Because now it's presenting something I'm not expecting.
It's probably actually Scott running a crypto mining operation.
Oh, if only.
Something else that I think is new in 9.0 is SSH has started making a backup of the known host file. I don't remember covering that in our What's New content, but it's kind of nice to know that just in case you mess up your known host file, it actually creates a .old. Scott, did you hear much about that? It just showed up
No,
on my lab systems one day.
Also new to me. Today was the first day I had noticed it.
So I've been redeploying my SSH keys here at home. I try and do that about once a year. Rotate all my keys, rotate all my passwords, and I noticed that. So that'll be worth looking into. But that's good to know that just in case, if you're like me and you just start hitting d in your Vim file that and you delete too many hosts, you can actually recover that from the old known host file. So let's go ahead and create. We're going to create a configuration file here, and let's see. I think it was Shantanu actually beat me to the punch here talking about the config file. So you can actually create a file under .ssh called config, and what this does is it basically creates. Automation may be too heavy-handed, but basically creates some logic towards logging in to a new system. So what Scott's just put in this file is taken from my home lab, and so I have, I guess I have a hybrid cloud lab environment because I have physical machines, virtual machines, and some machines out on DigitalOcean. So the first thing let's just step through this line by line. So if in the line that says include, we can actually create a subdirectory under .ssh called include, and that will pick up any configuration files that are in there. So if you have multiple different environments, maybe you have a production environment that uses one set of SSH keys and a dev environment that uses another set of SSH keys, you can actually create basically a config file for each of those environments. But in order for SSH to pick that up and to know to look in that directory, we've got to use an include statement. The identity file is the private key for. Goodness gracious, let me start that over. The identity file is the full directory path to the private key for the key that we want to use. In this case, we've got ID_RSA was the key that we created at the top of the show. And then, Scott, do you have a good explanation for identities only?
I do not, because this is your file. So that's one that I had not seen before.
So I've used it for years, and I've since forgotten what it is. I can look it up here in just a second. It's like my tmux configuration that actually had extra code in it that it didn't need. And then we could actually add a line in here that uses called hosts, which allows you to specify either a host name or some kind of regular expression for a host name. So when we first copy and pasted this over, it was a do dash, which means that any system in my home lab that we're trying to connect to that is on DigitalOcean, we use this set of keys. So in this example, we can change that out for host and then a space, and then we can type in client. So that'll work for both client 1 and client 2. We'll be able to use this SSH configuration for. Although before we run that, I believe we need to do an ssh-copy-id over to client 2.
I think I already did that. But let me do one other thing, because we're going to be making some changes to this in a minute. So let me limit this host to only one of the two systems. So we'll say that for client 1, this is what we're doing. And Eric, I'm cheating a little bit because I'm looking ahead at some of the things that we're going to be doing. And we can make those changes to client 1, but not to client 2, and actually show that the two are treated differently.
I like it.
All right, so we just save and go?
Yep. Oh, and the identities only yes means that it's not going to treat that stanza like almost like a wildcard entry. It is so that the SSH connection should only use the specified identity file. So it doesn't try to use anything other than the one that's specified. That's why I have that in my configuration file, because I've got multiple keys for multiple different environments.
Right, and it will try, if you SSH, it'll try all of your key pairs as your authentication credential. So yeah, that makes sense that we would say this is the only key that should be used in this connection with this system.
Especially if you're in an environment where your SSH retries are set really, really low, you can actually define in the SSH configuration file that you only allow 2 or 5 attempts before some action is taken. In more secure environments, you might run into a situation where someone can put in their password or specify a key only 3 times before their account's locked. I worked in the banking industry for a while, and that's what it was. You got 3 tries, then your account got locked out, and you got to take the walk of shame down to the help desk and say, "Hey, I was an idiot and I locked out my account. Can you unlock it?" And then they verify your account activity, and depending on the environment, may send a nasty gram to your boss. Fun stuff like that. But so that's why we want to use that identities only. Of course, now that I looked up the definition, it seems so obvious, but. Anyway, so now we've specified the SSH key, and yeah, always add comments to your configuration files. Great point. So now that we've specified a config file, let's go ahead and, okay, so Scott already did. Scott did an SSH to client 1. We put in the private key password, and we got connected in. So now if we do that from, I was looking at the wrong line. Perfect. So here's what Scott was mentioning. We're going to have some fun, and we're going to make some changes here. So on client 1, what we just did was we changed the default port for SSH from 22 to 2022.
Yes, and we actually, thanks to SE Linux, we got refused from that because port 2022 is not a recognized SE Linux type port. So I'm going to do something really naughty.
I hope Dan Walsh is not watching this episode.
Trying right now. All right. So
what we just did was we changed SE Linux. Yeah, we changed SE Linux from permissive, or from enforcing to permissive mode. So any actions that we take from here on out, SE Linux will put into a log, but it won't take any action. But just for the sake of the example, we're just going to set that aside. Dan, don't watch this episode. But now what we've done effectively is we've yeah, everyone close your eyes. What we've done is we've changed the default port from SSH's default port of 22 to 2022. So now if we were to go back to our main system and we'll need to okay, yeah, that works too. So now we tried to basically SSH into client 1 again, and we got a port we got a connection refused. That's because it's not listening on port 22. So there's two ways we can go about this. If this is a one-off situation, we can do a ssh-p and then specify the actual port, and we'll be able to get connected using our private key, just like we have been. But I don't want to have to type -p 2022 every single time I connect to a remote machine if that's going to be the way it's always done. So in that case, we can actually go into our config file, and I believe it's just port, and then 2022. So then if we connect again, we get a connection. We can put in our passphrase and get connected successfully. So now we don't have to specify the -p option, because what it's doing is SSH is looking at that config file going, oh, hey, this host name matches this stanza, so let me see, okay, so we're going to use this key on this port to get connected.
And remember we mentioned earlier that we were going to tie that stanza just to client 1? This is why, because what happens with client 2?
Yep, great point. Because now if we were to use that configuration file for client 2, it would be trying to connect over 2022 instead of 22. So so we already made that change. So this will work. But if we did a wildcard in our configuration file, then Scott's right. It would say that any host with the name client and anything after that would take that configuration. So instead, we tied it only to client 1. I wish I thought of that.
Wait, keep me around, Eric. And so this is great, like Eric was saying earlier, if you have different environments that require different things, you can actually make a host stanza that will say, here are the configuration options I want to use when connecting to this individual machine, like we did here with client 1. Or if we had all of our systems named client something, we could use a wildcard, say all of our client somethings should have these configuration options used.
So I think you added the next example on our list about disabling host key checking.
Yeah, so in that environment where like you're blowing up your machines and they get recreated and the host keys change, if we do a change to the host keys, it will refuse to connect to that box until the known host is cleaned up or the keys on the remote host are reverted back to their old state. And sometimes, like I mentioned, it might be not unusual for you to be connecting to a box where the keys have changed. Like you started with a cloud image, for example, and someone didn't bake the keys into the cloud image. So every time you connect, it doesn't look the same. Or a VM template or something like that. And so what you can do is you can use the option to disable strict or disable the host key checking. So again, we can do that via the command line with something like this. Where we're disabling the host key check. It'll just connect and use the authentication credentials it's used to using. And even if there's a mismatch, it'll just skip over it and connect. Or if this is a more permanent change that we should make for this host, we can put it in our configuration file. And it's been a minute since I've done that, so let's see if I can get it right on the first try.
So my spidey senses are tingling a little bit. I don't know that I would use that as a bandage. I would probably just thinking back to my sysadmin days, I think I would probably only use that in troubleshooting scenarios or in the case of a lab environment where I know that box is going to get blown up and rebuilt on a regular basis. But I wouldn't recommend using this for production systems in the long term.
Yeah, and where I've used it in the past is when I worked in the Red Hat training and certification team. Um, you would show up to a facility and stand up a new classroom for your students that week. And the next week, you'd be doing it in a completely different place. And the next week, you'd be doing it in a completely different place. Well, the systems all have the same IP addresses and all have the same host names, but every week, because it's a fresh install, their host keys are all different. And so for us, it was really common in that environment to disable the checking because, like, I know that there's going to be a mismatch. I don't care. I still want to connect to that IP or that host name, and not be annoyed with, an error out of the SSH command.
And Jack jumped into chat and shared a great point. Doing the host key skip or doing the host key check skip is a great idea if you're doing loops. So if you're running some sort of bash automation and you're doing some remote configuration on systems, that's a great way to automate your scripts so that you don't get prompted with that, hey, it looks like you're connecting to a system you haven't connected to before. Would you like me to add this to the list? By doing that host key skip, that check skip, your bash script won't error out. So a lot of good utility type use cases for this, but not recommended for production use. So one other thing I wanted to bring up was that we ran into an SE Linux issue when we changed the port, but Shantanu also pointed out that if we were to make that change on a production system, we would need to make that change in the firewall as well. We'd need to allow port 2022 for this example to work. Just because of our lab environment, we've got 3 systems in this environment, and they're on sort of an internal network where just everything's allowed internally between the 3 of them, which is why that worked. But yeah, good point. So if you're following along at home and you're trying this example and you run into an issue, check your firewall. You may need to open up port 2022. Let's see. I think that's all the questions. Scott, did you have any closing thoughts?
No, I think that covers it. I'm going to go ahead and put my machine back into enforcing mode, though. So I don't like to be permissive.
Well, luckily, one way or the other, that machine's going to die in the next 25 minutes. So that's the nice thing about ephemeral lab environments. All right, folks. Well, thank you so much for joining us. Great conversation in the chat. Really appreciate folks showing up to hang out with us on a Friday afternoon. So for next week, I'm sorry to say, but Red Hat offices are closed next week, and Scott and I are going to enjoy some much-needed time off. So there will be no episode next Friday, the 12th. But we'll be back live the week after that. Same bat time, same bat channel. Hopefully no one does a copyright infringement on that. But join us in 2 weeks for an episode on population management. We're going to talk about RHEL lifecycles. We're going to talk about extended update support, and maybe a few other goodies around how to get more out of your system's lifecycle. So with that said, on behalf of Mr. Scott McBrien, the entire Red Hat Enterprise Linux team, and myself, thank you for joining Into the Terminal, and we'll see you next time.